This video is about scientific notation, a quick recap. So scientific notation allows us to represent really big numbers and really small numbers. Essentially, this is the only time that you will leave a negative exponent in an answer, because normally it's bad algebra manners to leave a negative exponent in any of our answers. And lastly, the rule that you need to follow is that only one significant digit will precede the decimal on the left. So these are the basics to remember about scientific notation. Of course, scientific notation is also all multiplication. Therefore, the commutative property and the associative property also applies here. So the first thing we're going to do is some basic conversions to scientific notation from a standard notation. So both of these are in standard notation. And the first thing we need to do is determine what power of 10 is necessary, and the easiest way to do that is just count the number of moves of the decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to be moving that decimal 10 places to the right, and pretty much anytime that we're moving to the right, our power of our 10 is going to decrease. So 10 places to the right, only the 1 is going to precede the decimal there. So our scientific notation is 1.23 times 10 to the negative 10th. Why? Because we moved the decimal, shifted it 10 places to the right. Next, we're going to the left, and this time I'll just count by threes. 3, 6, 9, 10, another 10 places, but this time 10 places to the left. And when we move to the left, obviously we are increasing our number here. So this is 4.23 times 10 to the positive 10. So negative powers of 10, remember a negative exponent represents a reciprocal. So when we're multiplying 1.23 times 10 to the negative 10th, it really means the same thing as 1.23 times 1 over 10 to the 10th. And 10 to the 10th, if you recall, I'll just let you see it. 10 to the 10th is a pretty large number. There it is. Well, even the calculator gives it in scientific notation. So here's your calculator. It's going to say 1e10. That's just the shorthand way of saying 1 times 10 to the 10th power. So this is a conversion to scientific notation. We're moving the decimal to the right or to the left. So now we're going to convert to standard notation. Still, we're just going to be shifting the decimal. So if we have negative 6.24, and we're multiplying it by 10 to the 7th, that decimal, since 7 is positive, just needs to move to the right 7 times. 1, 2, 3, 4, 5, 6, 7. So there we go. So that would be negative 62,400,000 is the standard notation for negative 6.24 times 10 to the 7th. Let's go in the other direction now that we are representing a very small decimal number. So 1.375, we are going to shift the decimal 6 places to the left. 1, 2, 3, 4, 5, 6. So there's the decimal. Fill in with zeros. And if you like, you can put a 0 out front, but that 0 that precedes the decimal, really unnecessary. And good grief. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths. So this is 1,375 millionths. So crazy number. Crazy small number. Next, we're simplifying here. Remember, simplify and evaluate essentially mean the same thing. So we have two scientific notations being multiplied together. So this is what I was saying a second ago. We can employ the commutative property and the associative property and change the order and the groupings and deal with this product of scientific notations. And this is pretty much also the only time that you're going to use the X, because normally if we write X, it means X. So I just changed the order and I put the two coefficients together, and then I put the two powers of 10 together. So now if we go to our handy calculator, 6.1 times 7.5 is 45.75. And of course, 10 to the 7th times 10 to the 5th is 10 to the 12th. So now we need to shift our decimal 1 to the left, because right now 45.75 has two significant digits in front of the decimal. So we have got to decrease that coefficient, which means that we have to increase our power of 10. If we move the decimal to the left, the power of 10 is going to increase. We're shifting it 1 to the left, so that will be 4.575 times 10 to the 13 in correct scientific notation. And let's do the bottom once again. This is division, but if we think about it as two separate fractions here, that is following the properties of algebra. So basically we're just inserting some grouping symbols here, since this is essentially multiplication of fractions. And now let's just reduce each of the fractions. So 1.85 divided by 3.2 gives us 0.578. We'll stop there. We'll just round that there, because following the 8 is a 1. So 0.578 times, and then we have 10 to the negative 4th over 10 to the negative 6. Remember our property, our quotient property for exponents. The bases are the same. We're going to subtract those exponents. So negative 4 minus negative 6, you need to write it and look at it. Negative 4 minus negative 6, negative 4 plus 6, that's 2. So we end up with 0.578 rounded to the nearest thousandth times 10 to the second power. Now, once again, this is not in correct scientific notation. This time we've got to shift the decimal one place to the right. And when we shift to the right, we need to decrease that power of 10. So 5.78 times 10 to the first. So correct scientific notation, one significant digit in front of the decimal.